everyone, I'm Ramon Arrowsmith. I'm a professor in the School of Earth and Space Exploration at Arizona State University, and I wanted to provide just a very quick welcome and overview to my research group. And our laboratory is largely in the field, and also we use a lot of high-resolution topography, and so wanted to just use this as an opportunity to show some cool imagery. So this is a strip of meter scale topography along the San Andreas Fault in Central California. See these really kind of cool, strange patterns of the structures. Here's a double stranded piece of the fault zone, and things that are interesting to me is how does this structure evolve? How does it record the history of past earthquakes along this really major fault of California? And here we're flying to the southeast, and we come to the southern Carrizo Plain where the data kind of broaden the topography hillshade, and this really spectacular feature called the Dragon's Back is here. It's about 3 kilometers long, parallel to the fault zone. It's several hundred meters wide, and it's about 150 meters tall, and it records kind of progressive uplift and offset along the fault zone, and has been a natural laboratory for us to look at the interactions between topography or surface processes and tectonic processes. And this also was part of my PhD work, so always kind of close to my heart. Moving on, here's another really interesting project we've worked on. This is a point cloud that was rendered in the browser, and it shows us the topography. This is about a kilometer in scale over a volcano in northern Mexico, just south of the US-Mexico border. It's called the Tecolote volcano, and I've been working with Professor Amanda Clark to understand what's going on here. You see these really interesting fractures that are sort of concentric around these vents in the middle here. So this was produced from a drone, and this and the prior data are available on the Open Topography project, which is a major data sharing project for topographic data that I help lead. And then here's a final view of another interesting project. Something that makes me quite excited is the example of an earthquake surface rupture that is from 2008 actually, but we were in the field a couple years ago, and you can see some people down there at the bottom. And actually also, if you look very carefully on the right in the middle, there's a white thing is another drone flying. But we're using the topography data from the drones and also our field mapping to understand the fracture pattern that was associated with this earthquake rupture. And you can see people there making measurements in the field to compare with what we observe from the air. But this is probably an unusual earthquake. It probably hasn't happened that many times in this particular fault zone, although there is some evidence of prior events in the landscape. And unfortunately, it was devastating to a local village, and so it reminds us about the importance of studying this phenomena. So anyway, please don't be shy. If you have any questions about these topics or other ones, please communicate with me, and best wishes.